Okay, so looking at this question, this is actually a very advanced question. I'm just going to show you how to do the answer because we don't have a lot of time. So basically, what is it asking? It's saying n is a number. There's the prime. They're giving us the prime breakdown for n, and they're asking us how many divisors does n have? That is, how many different numbers can divide evenly into n? That's an interesting question. What you have to do is you just have to add 1 to each power, then multiply these numbers together. It's just 2 steps. So I'm just going to come down here. I'm going to add 1, add 1, add 1. So I'm going to add 1 to each of those powers. 6 plus 1 is 7. What did I just write there? 6 plus 1 is 7 times. Take the next one. It's also 7 times. And then the third one, 3 plus 1. And just simply take your calculator, go 7 times 7 times 4. 196. And that's our answer. Now, I hate teaching math that way. I hope you won't teach math that way. I just showed this like it was a magic trick. Like there was no logic in that, was there? There was just a, hey, do this, it works. Well, that's just like a trick, and that's not interesting, right? That's just memorizing a trick. So let me show you why. Why is that true? Because that's what math is about. Math is about learning to think and describe and understand logic better and better and better. That's why we study math. That's why we force even people that are not becoming math science people to take math, because it trains their brain to think more logically, which is valuable in everything we do. So what's the logic here? I hope you will teach math that way to younger folks. You'll teach them to think and reason, describe and understand. So let me reason with you. Why does this work? Well, if you think about it, if you get back to this original question, we had 2 to the 6, 5 to the 6, 7 to the 3rd. If that was n, and we were saying how many different numbers divide in. Well, if I had a single 2, will that divide in? Well, of course, because we have room for 6 2s, don't we? So 2 to the first one, if I had 2 squared, would that divide in? Well, of course, we have room for 6, etc., all the way to 2 to the 6th power, right? We could have had any of those options, couldn't we? Would all divide in. I could have had 2 to the 1 or 2 to the 2 or 2 to the 3 all the way to 6. Or, by the way, I could have had no 2s. Is that making sense? I could have had 2 to the 0 power. You could have had 2 to the 0 power. That would have worked also, right? You could have no 2s, in other words. Let me just write no 2s. You could have no 2s. So you could have no 2s, 1, 2, 2 2s, etc., all the way to 6. So if you think about it, there's 7 options. There's 7 options for how many 2s you could have had. Everybody see that? You could have had from 1 2 up to 6 2s and no 2s. There's 7 options. What about when it comes? See that's the power, the 6 power plus 1. See how that's just 6 plus 1? That's why we're adding 1 to each of the powers. But what about when it comes to 5s? Same thing. We could have had 1 5, 2 5s, etc., all the way up to 6 5s or no 5s, right? There's room for 6 5s, 5 5s, 4 5s, 3 5s, 2 5s, 1 5, or no 5s. There's room in there. So again, that's 7 options. And finally, when it comes to the 7s, there's room for 1 7, 2 7s, 3 7s, or no 7s, which is 4 options. See how it's always 1 higher than the power? Because there's room for none. And then why do we multiply these numbers together? Well, because that's how options work. For example, if you have two different pair of shoes and two different hats, if an older gentleman has two different pair of shoes and let's say three hats he likes to wear, how many different shoe hat combos are there? If you multiply those together, there's 6 different combos, right? He can wear the first, you can see it like branching. He can wear the first shoe or the second shoe. And with the first shoe, he can wear the first hat, second hat, third hat, or with the second pair of shoes, first hat, second hat, third hat. See how in the end, there's 6 combinations, right? You multiply those numbers together when you have combos with combos. Well, that's what we have here. You have 7 options, and 4 options for all the different kinds of numbers that could divide into this number, right? They could have 2 2s, 5 6s, 6 5s, and 2 7s, or any other option therein. 7 options, 4 options, multiply those together, 196 options.